Hello, welcome to SEPAM. Today we're going to be looking at the solution to Mathematics Checkpoint April-May 2024, Paper 1, solved by Orisheje Matthew. So let's jump in and see the total mark for the mathematics exam is 50 mark. I want you to subscribe, like and share, and then you have an opportunity to book an online coaching class with me as you are preparing for your checkpoint examination, and I'm available to guide you to get the distinction that you need in this particular exam. So let's go in and look at this one. So question number 1, Joseph thinks of a number n and he adds 3. So when you add n plus 3, so he adds 3, his answer is greater than, so that means n plus 3 is n plus 3 is greater than or equal to minus 5. That is 1. And then his answer, n plus 3, is less than 17. So the answer is greater than or equal to minus 5 and less than 17. So these are the options. So we can put it. So in this case, if n plus 3 is greater than negative 3, for example, what will you say about 3 and 5? You will say 3 is less than 5, and then 5 is greater than 3. So we can say that. So consequently, this is minus 5 is less than or equal to n plus 3, and n plus 3 is less than 17. So that is for 1 mark. Then the second one is question 2, find the value of w. So what we need to do, write this left hand side, take this one to the numerator as an indices. So you have 200 raised to power negative 3 is equal to 200 raised to power negative w. So since the denominator is equal, the base, so this is the base, 200 and 200 is equal, then you can equate the power. So therefore negative 3 is equal to negative w. So which means negative cancel negative, w is equal to 3. So let's look at question 3. This has to do with a simultaneous equation. So if you look at this equation, so we can call this equation 1, and then this can be equation 2. So if we solve it simultaneously, what you can do, if you look at the value of these 2y, you have the same coefficient, so we can eliminate that. So, and then equation 1 is s minus 2y. So if you have minus 2y plus 2y is equal to 0. So that means we are going to add equation 1 and 2. So you do equation 1 plus equation 2. So let's see that. So that will be x plus 5x, then you have minus 2y plus 2y equals to 2 plus 58. So this will give 6x, then this is 0 equals to 60. So 6x equals to 60. Divide both sides by 6. X is equal to 60 divided by 6 to give 10. So x is 10. Then to get y, we can replace s equals to 10 in equation 1. What is equation 1? X minus 2y equals to 2. So we are looking for y, so that will be 10 take away 2y equals to 2. So that means 10 take away 2 is equal to 2y. So, well, let me take it up here. So that will be, right, 8 equals to 2y. Divide both sides by 2. Y equals to 4. So y is equal to 4. All right. So let's go to question 4. I just want to take it directly so that our answer can be. So find the exterior angle of a regular 10-sided polygon. 10-sided polygon. The number, for example, let me just draw this here. If you have this, if this is a polygon, for example, okay, okay, now what this means is, if here is n, here is n, here is, so when you add all this number together for n-sided, so since there are 10-sided, that means 10 times the number of external angle is equal to 360 degree. So since there are 10 exterior angle in a regular polygon, so if you add all the exterior angle together, n is called the exterior angle, while this angle here is called the interior angle. So this is the interior angle and n is the exterior angle. So we have 10n equals to 360. Divide both sides by 10. So that would be n equals to 360 divided by 10 to give 36 degree. 36 degree. So that is the angle, the value of the angle. Then the next, let's look at question number 5. Has to look at what? Term to term. This is on a sequence calculation. So if you look at this sequence calculation, okay, so if you all right, so let's look at this. 1 multiply 7 take away 2 multiply by 1 is equals to 5. Then 3 multiply 8. If you look at this point here, this number is increasing by 2. 2. 2. 2. All right. why this is increasing by 1 1 1 1, and then here also is increasing by 2. Take away 2, then the next one you take away 4. So here you take away 2, then here you take away 2. So the next number, this is 11 times 12. So after that, so what will you do? Add 2 to this one, so that is going to give us 12. Multiply. If you see this is increasing 1 2 3 4 5, then the next one here is going to be 6. Okay, then you can collect like term. So if you look at this and this, both are multiplied by 12, so we can bring out 12. So take away 11 minus 6. So the answer is 12 times 5. So the answer, the next term is 60. So let's go to number 6. I'm trying to not to give too much explanation so that the video, the timing will not be too long. Okay, so we have a regular polygon has scale line of symmetry. Okay, tick the correct statement about the order of rotation, of rotational symmetry of the polygon. The order of rotational symmetry is 1. The order of rotational symmetry is clockwise. The order of rotational symmetry is k. Then the order of rotational symmetry is k plus 1. Okay, so let me just explain something. The answer is the order of rotational symmetry is k. So that is the correct answer, but let me explain what they mean by rotational symmetry. So for example, let's look at maybe a triangle where all the sides are equal. So let me bring out a triangle here. So we can look at this triangle. Okay, so if you look at this triangle where all the sides are equal. Okay, so let's look at this triangle. If all the sides are equal, so this is we have this is equal to this and is equal to this. So this is a three-sided polygon. Now if we want this three-sided polygon, what is going to be, let's draw the line of symmetry. So the line of symmetry is going to be, let's pick a line to get the line of symmetry. So you can do this. So we have this one. So we have that one line. Then can have another line here. Okay. Then can also take another line here. Okay. All right. So the line of symmetry, so for a three-sided figure, is going to have what is the number of order of symmetry, rotational symmetry. So for 3 is 3. Then order of rotational symmetry is going to be, so if you once you know the number of angle, this means that when a triangle is rotated through 360 divided by n, 360 degree divided by number of side. So if it's rotated through, for example, so if it's three-sided, once this triangle is rotated through 360 divided by 3, is going to give me 120 degree. So once I rotate this angle, this triangle, so if I call it A, B, C, if I rotate it through 120 degree, the triangle will become the same shape. Okay, so that is the angle of rotational symmetry. So what is the number of rotational symmetry? Is equal to the number of line of symmetry. So most time the number of symmetry is equal to n. Okay, so let's go to the next question. Question 7. Okay, question 7. The two lines, Mark and Pierre, were each asked to write the equation of two lines that have a positive intercept. Two lines that have a positive intercept. So first of all, let's have a sketch of the line. Let's have a sketch of the line here. So let's look at the sketch. So if we have these 2 points here, if I have this line down, okay, that is a y-axis. Then you have the s-axis. Okay, and then if you draw a line with positive intercept is a line, any of this line has positive intercept. Okay, this point here is a point of intercept, so that is the B. Okay, why the gradient of this line is, we can call it M or A. So the line is y equals to a, oh okay, I've used ax plus b. So b is the intercept on the y-axis, ya is the gradient, or it can also be written as ms, where m is the gradient, plus b. So this is the intercept, while this is the gradient of the line. And if it is positive, m has a positive value. So m has a positive value. So all you need to do, rearrange all this one. So this, now, so we are looking for the y-intercept, positive y-intercept. So this is plus 3, this is positive. Positive y-intercept, this is plus 2, so it's positive. So correct. Then positive y-intercept, that is 1/2. Positive y-intercept plus 7, so that is correct. So both of them are correct. Now, the equation question 7b, the equation of the line 7 equals to 3x plus y. Find the gradient and the y-intercept of the line. Okay, I think I've already explained this before. So we have this, so let's rewrite it in form of equation of a straight line. So you have right, y equals to 7 take away 3x. So y equals to negative 3x plus 7. So compared to normal equation of a motion, y is equal to mx plus b. So b is the intercept. So what is the intercept? Compare. So the intercept is 7. Then what is the gradient? The gradient is negative 3. So the equation of a straight line. Now let's look at question 8. Okay, put a tick to show each conversion is correct or not. Okay, 60 nanometer is equal to 6 millimeter. Oh, you wonder why I'm laughing? This is not correct. Okay, let me explain. Nanometer means 60 nanometer, that is 60 times 10 raised to power negative 9 meter. And then 6 millimeter, so it's not equal to 6 times 10 raised to power minus 3 meter. So the power is not equal, so they are not equal. Then we have 2000 gigabytes. So we have the next one is 2000 gigabytes, which is what? Times 10 raised to power 9 bytes. Let's see, is it equal to 2 times 10 raised to power 6 bytes? So megabyte m. So they are not the same. So they are not the same. Okay. So if you have to, all you need to remember here is the subdivision of units. So let me just explain. Centimeter is equal to 1 times 10 raised to power minus 2 meter. Okay. Then kilometer is equal to 1 times 10 raised to power 3 meter. Then we have mega. Okay, so that is mm. Okay, that is 1 times 10 raised to power 6 meter. Then gigameter, which is the same thing as 1 times 10 raised to power 9 meter. So this is for units that are bigger than 0. Then for subunits, so you have centimeter. Okay, you have centimeter 10 raised to power 2. Then you have millimeter 10 raised to power minus 3. Then you have micrometer 10 raised to power minus 6. You have nanometer 10 raised to power. So this is 10 raised to power minus 2. This is 10 raised to power minus 3. Divide by 1000. This is divide by 1 million. Then this one is divided by 1 billion. All right. So let's go to number line. So represent the number on a number line. For example, what is this? So if we say negative 2 is less than x, this implies that s is greater than negative 2. S is greater than negative 2. So on top of negative 2, draw a line, a 0, but you don't shade it. If I shade it, that means it's going to be greater than or equal to. Okay? Then the next one is x is less than or equal to 4. So you go to 4. So less than or equal to, so you shade it. So next, you can now connect the two with a straight line. Alright, so this is the diagram. Okay, so this to show you that negative 2 is less than x, and then s is less than or equal to 4. Okay, question 10. Question 10. The diagram shows the shape made with 3 identical rhomboses. Okay, now find the value of x. So we want to find the value of x here. So we are interested in the value of x. Okay, now for us to be able to get the value of x, so if you add all these points together, this point here at the middle will give you 360 degree. Okay, so let's call this point S. Let's call this point here A. So this point here A, this point here A. So we have 70 plus 3A, then there is 3 times 70 will give us 360. Okay, so we have what? 210 plus 3A equals to 360. All right, so we have 3A equals to 360, take away 210. Okay, so 3A equals to, so can we subtract that? 60 take away 10 is 50. So 300 take away 200, 100, so 150. So A is equal to 150 divided by 3, so which is 50 degree. So here is 50 degree. And then this angle here, so they add together because this is parallel to this. Okay, and then remember, when you have a parallel line and then you have this, okay, so the angle here, so which is x, and then the angle here, which is 50 degree, so this angle add up to 180 degrees. So x plus 50 equals to 180 degree. So x equals to 180, take away 50 degree, so that will give us 130. Okay, all right. Okay, so let's look at this. Gabriela collects the height of 11 indoor plants and 12 outdoor plants. The table and the incomplete back-to-back stem and leaf diagram show information about our results. So this is the outdoor plants. Now the outdoor plants, so we'll talk about the outdoor plant, which is the right hand side. Okay, now what do we mean by the modal height? The modal height is the height that is most occurring, the most frequent height that was collected. The minimum height is the lowest height, and then the range is the difference between the minimum and the maximum. So if we are given the minimum, then we cannot get the maximum height. So we have range is equal to maximum height, the max value, take away the minimum value, which is 17. So we have right, so we have the maximum value is equal to range plus minimum value. So that will give us what is the maximum value of the adult plant. That is going to give 17 plus 26. So we have 3, that is 43. So that is the maximum value. Okay, so with that, so let's complete, represent the indoor plant. So 26, when you are talking about your stem and leaf, the unit value is the stem, the unit value is the leaf, while the tens value, so you have tens and units. So if you do this, tens and units. Okay, so from here let's predict. So for the outdoor, so what is going to be, so this is 41, and what is the maximum value? So we can put here 43. Okay, we were told that the mode of the adult plant is 39, and then here you have two numbers that repeated themselves, 7. So for 39 to be the mode, that means the 39 must appear more times. So you are going to have what? So you have 34, 35, 38, 39, 39, 39. So that will give you the value at this point. And then from this value here, we are told that the minimum value is 17. So this is 23. 23 is the smallest value here. So we can create a minimum value. So which is to give us 17. Then take note of the information given here. You have how many indoor plants? 11. How many outdoor plants we measure? 12. So let's count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So we have completed the outdoor plants. So now let's look at, so we were asked to complete the information on the table, okay, about the outdoor. So now use the information. So use the information in the table to complete the back-to-back diagram. We have done that. We've completed the diagram. Now calculate the range of height for the indoor plant. Indoor plant is this information here. So we have this. So from this point to this point, so this information about the indoor plant. Okay, what is the range? So if we want to calculate the range, so we have the number is what? The indoor plant that we calculated, you have what? 7, 8 cm, then 9 cm tall. Then you have 1, 14. So let's just write the data from the smallest. So the data that you have here of the indoor plant, let's arrange it from the minimum to the highest. So you have 7, you have 8, you have 9, then we have 14, we have, that is this and this 14, this and this 15. So let's go. We have 15. What is the next one? 19. What is the next one? Then 19. There are two plants with 19 cm. Then come to this point here. So you have 26, 28, 29. So the next one is 26, 28, 29, stem and leaf. Then the biggest here is 30. Now 40, there is nothing. But remember, we were told that there are 11 of them. So let's count if it's complete. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So the indoor plants are correct. So let's calculate the range. What is the range? The range is lowest, so maximum value minus lowest value. So what is the range? What is the range of the height? So you have 30 cm, take away 7 cm. So that is equal to 23 cm. So that is the range of the plant. Okay. Okay, so let's go to question 12. Very good. Question 12 had to do with power. So substitute. So we're asked to substitute, work out the value. N raised to power 4 plus 29 divided by n plus 7 when the value of n. So anywhere you see n, replace it by 3. So this will be numerator 3 raised to power 4 plus 29 all over 3 plus 7. So 3 raised to power 4 is the same thing as saying 3 raised to power 4 is the same thing as 3 times 3, 9, times 3, 27, times 3. That is equal to 81. So this is going to be 81 plus 29 divided by 10. So this is one of the easiest questions. So your answer is going to be 110 divided by 10. So that will be the 0 will take care of 0. So answer is 11. Question 12. Now write 62,000 in standard form. So 62,000 in standard form. So this is saying 62,000 in standard form is saying 6.2 times 10. So you count after the decimal point. How many numbers are there? So 1, 2, 3, 4. So that is 10 raised to power 4. Okay, now write. Okay, so let's look at this one. Write 2,300 in standard form. That will be what? 2.3. Then count 1, 2, 3. So that is times 10 raised to power 3. Okay, that's for positive. Now write 8.1 times 10 raised to power negative 3 as ordinary number. So what this one means is 81 raised to power 10 raised to power 3, that is divided by 10 raised to power 3, which is the same thing as, this is 8.1 divided by 1,000. So that means you take it how many times? 1, 2, 3. Shift the decimal point 3. So you replace here. So you take your decimal point. So how many number? 1, 2. So you have 2 0. Then you have 8. Then you have 1. So you shift it. 1, 2, 3. Okay. Okay. Congruent. Okay. The diagram shows the shape made from 6 congruent equilateral triangle and a regular hexagon. Very good. Equilateral triangle and a regular hexagon. Okay. What the area, the regular hexagon has the area of 140 cm square. Calculate the area of the, calculate the shaded area. Calculate the shaded area. So this. Okay. Now, if you look at actually what is happening here, okay, let me illustrate something here. If you do this, so let's complete this diagram and see. Okay, I think I'm correct. Okay. No. Okay. Then do this. Okay. Now if you look at the hexagon, can we count? 1, 2, 3, 4, 5, 6. So if they tell you that the area of the hexagon is 140, so this one is a net shape, so we can flip this. This can represent triangle 1. Then this will cover triangle 2. And then this will cover triangle 3. So what you are left now, the area of hexagon, this one will be the area of hexagon divided by 2 will be the area of the shaded portion. So area of shaded portion, area of shaded portion is equal to 140 cm square divided by 2. So that will be, so the area, so because there are 6 of them, then 3 of them, because the portion of the what fraction of the hexagon is shaded. So this is it. So let's shade this. Sorry, let me pick a different color so that when you are going through this you can understand. Okay, let's shade this part here. Let's shade this. Okay. Okay. Very good. So what portion is shaded? Very good. Okay. So can you see? So that gives us to half of 14, 7. So 0 cm square. So it's 70 cm square. Okay. Now the table show information about the mass of each of 23 buses. Okay. On the grid, draw a frequency polygon to show this information. Okay. Okay, when you are plotting this, you use the middle value. So we use the middle value when you are plotting. So the middle value from between 4 and that is 6. And then what is the 6 and what is the frequency? 8. Okay, then between 8 and 12, 8 and 12 is 7. So midway between 8 and 12 is 10. Okay, then between 12 and 16 we have 3. All right, to complete the frequency polygon, the next thing we need to do is to join the line. So you connect the line, the midpoint, the frequency, so you connect it to this. Then from that you connect it to this line. Then connect this line to this line, and then you come to this point. So this is the frequency polygon. So with this we have completed the graph of the frequency against the midpoint of each of the buses. Draw a ring around the interval that contain the medial mass. Okay, now the medial mass, there are how many value are there? How many of them are, we say where there are 23. So if you arrange 23, so let's look for the middle value. 23, where is going to be the middle of 23 from the lowest to the highest? So you have 23, half of 23, so 23 divided by 2, that is going to give us 11. Okay, so let's look at this. So we have 8 plus this, that is 17. So the middle value is going to be in this class. The medial value is going to be in that class 11, the 11th mass. So this 8 plus 3, the third, add it to it to give us 11. So the value is here. So it's going to be the value that have the mass from 8 to 12. From 8 to 12. Draw a ring. So let's do that. To 12 is that. Okay, very good. So let's go to the next question. Oh dear.